De Moivre's theorem can also be used to prove trig identities. So let's take an example. Let's have an example. The example identity is prove that sine 3 theta is equal to 3 sine theta minus 4 sine cubic theta. So we want to prove this identity. Prior to the De Moivre's theorem, you can make use of compound angle identities to prove this. But we want to make use of the De Moivre's theorem. How do we go about it? Now, for us to get sine 3 theta, it means we had the De Moivre's theorem raised to the power 3. So this was cos theta plus I sine theta to the power 3 equal to cos 3 theta plus I sine 3 theta. So that's where we now have the sine 3 theta. So let's expand the left side. So if these two are equal, so it means when we expand, we then compare the real part, and the real part must be equal, and then the imaginary part must be equal to the imaginary part of the right side, which is sine 3 theta. So let's expand this using binomial expansion. So that's 3 choose 0 cos cubic theta plus 3 choose 1 cos squared theta I sine theta plus 3 choose 2 cos theta I sine theta equal to plus 3 choose 3 I sine theta to the power 3. 3 choose 0, that's just 1. Plus cos cube plus 3 choose 1, that's 3. 3I cos squared theta sine theta. I squared, you get minus 1, so 3 choose 2, that's 3. It becomes minus 3 cos theta sine squared theta. And then I cubed, that's I minus 1 times I, so that will give you minus I. So 3 choose 3, that's 1, so it gives us minus I sine cubic theta. So now the next part will be to compare the imaginary parts. We have this and this, that must be equal to sine 3 theta. So we take sine 3 theta and say it is equal to 3 cos squared theta sine theta minus sine cubic theta. So remember the identity, it does not have any cos, so we want to eliminate the cos squared, and then we express it in terms of powers of sine. So cos squared, by the identity cos squared theta plus sine squared theta is equal to 1. We eliminate cos squared, it becomes 1 minus sine squared theta sine theta minus sine cubic theta. Let's expand that, becomes 3 sine theta minus 3 sine cubic theta minus sine cubic theta. It gives us 3 sine theta minus 3 sine cubic theta minus sine cubic theta. It becomes minus 4 sine cubic theta, which is now equal to the right side. So it's equal to the right hand side. Sure. So that's how we make use of the De Moivre theorem in proving trig identities.